All right, once again, good morning, everyone. Welcome to our Wednesday webinar. For this webinar, we will be covering Creo Advanced Assembly functions using Assembly Advanced Extension. For this webinar, we will, of course, cover some of the options available in Advanced Assembly Extension, being skeletons, some shrink wrap, and then, of course, using interchange groups. We'll do a demonstration of that, and then, of course, following that will be a Q&A. If you do have any questions, you can enter them in the webinar dialog box. There is a question section. You can enter in your questions there. I will either answer them as they come up, depending upon what the question may be, or I more than likely will just wait till the end and answer all the questions at the end of the webinar. So my name is Michael Wimberly. I have been with PDSVISION for 10 years now, over 10 years now. Excuse me. I've worked with PTC products for over 25 years and been a part of the PTC channel doing training and implementations for over 20 years now. I'm a certified trainer as well as implementer of Creo and Windchill functionality. As far as PDSVISION, of course, we were formerly known as Boundary Systems, for those that may not be familiar with the PDSVISION name, but are familiar with the Boundary Systems name. As of the beginning of this year is when we made the complete switch over to fully just PDSVISION. We are a technology leader. We are PTC's first global reseller and service provider. As you can see by the map on the screen, we have locations, of course, here in the United States, also in Canada, and then over in Europe and Africa, South Africa, the Middle East, even over into the Asia areas. So we have resources all over the globe that are available to help. So for those companies that have locations in multiple countries or multiple continents, we're able to assist with that as well. Some of our capabilities, of course, are consulting, implementation services, professional training, cloud services, and of course, our help desk. Just for the timeline, Boundary Systems itself was established in 2006. We became a preferred Windchill partner in 2008. We expanded as Boundary Systems globally into South Africa in 2014. And then we actually joined with PDSVISION Group in 2018. And as I just mentioned, officially in 2022, we fully changed our name over to PDSVISION. Some of our partners, of course, we work directly with PTC. We sell the majority of the suite of PTC products. We also have additional software that we use or that we support. Tacton, Modex 3D, Xformation, eTrage, Sigmaxim, ZWCAD, Keyshot. We also partner with other companies that will help to create applications that will help associate two pieces of software to talk with each other that may not initially talk with each other. So that's one of our partnerships with ITI. And then we also have Cimerix that we also partner with. As far as the digital thread is basically, it provides a comprehensive approach to go in for the multiple applications of softwares within a company. As you can see, it contains 4 major rings. The inner ring is basically for your product virtualization, such as creating the actual product themselves using your CAD tool, technical publications, even managing that data. And then from there out, we deal with some of the processes such as bond management, change management, project management, quality, all those different things that are associated with the products that we've designed. The third ring out now deals with manufacturing. So now we're talking about the manufacturing process, 3D manufacturing, additive manufacturing, model-based definition, even ERP integration falls into that one. And then from there, we now get into some of the smart products, such as some of the IoT things and the AR items that we associate with. So with this digital thread concept, we're now going in and taking our initial design that we normally would just see in the CAD realm, and we're now expanding it into multiple areas inside of our company. So we're not just keeping it in engineering, we're going all the way out to the IoT realm, where that can incorporate website design, it can incorporate services, where we can create a video that actually shows a service tech how to go through it and actually change something out by simply scanning a little barcode. So there's a lot that can be done with our data using digital thread. And this slide here just simply shows kind of a general thread of how things are connected. So a lot of times inside of our companies, we have things that are in individual silos. So things are done individually and not fully connected. So sometimes what's done in engineering isn't properly conveyed to what's done on the shop floor, or the shop floor into service parts, all those different things. The digital thread, once again, allows communication in all those areas so that there is no lack of communication and everybody's still looking at the latest and greatest information that is being designed. Now, what we're looking at when it comes to advanced assembly functionality, of course, we're now focusing a little bit more on the CAD side of that, which is our product visualization. But also keep in mind that when we do build up our CAD, that immediately can be transitioned to the next ring, which basically is BOM management, because we are creating our CAD file, which will propagate into a BOM that we can go through and use as well. So those things will continue to go out. And then once again, from our CAD file, we can then go into additive manufacturing for our 3D printers or things like that, or even creating our manufacturing programs from those models. So as you can see, it may start with the base CAD file, but there's so many pieces in our production environment that can be tied to that single CAD file. All right, so the first thing is just dealing with skeletons. So skeletons allow you to take advantage of top-down design, concurrent engineering, and data sharing. So with that, we start with the skeleton, which is simply just an outline of what it is that we're working on. So this is the concept of what the shape we want it to be, the confined areas. Even as you can see with this little skeleton, we have these little holes here, which represents where the little rivets or screws are going to go in to make sure this thing's connected properly. So we go through and we put all that into a skeleton model. And then what we'll do with that skeleton model is, as we design the different pieces of this knife, we can now go through and copy this skeleton geometry, which is basically curves or surfaces, into that part and now use it to guide us in designing that part. One of the other things that is beneficial is also being able to use multiple skeletons. By default, in a single model, you're only allowed one skeleton, but there is a config file option that says multiple skeletons allowed, and you set that to yes. The benefit of that is you can actually create multiple skeletons for multiple design groups. So there may be a focus area, and for just, let's take the knife. So we may have a skeleton that deals with the handle of the knife. So we put all the data that's necessary in that handle in that skeleton. Well, there's another group that may be dealing with just the blade end of it or the mechanics of it. So we can actually create a second skeleton that has just what they need in it. And now each one of them can pull from their appropriate skeleton model. So this is a very simplified model, but once you get into larger assemblies, like we're going to look at in just a little bit, there's a lot more that we can do with skeletons and the advantages of using multiple skeleton models. All right. All right. Then we also talk about shrink wrap. With shrink wrap, what that does, it reduces model load time and increases system performance by providing the ability to create and share a smaller file representation of a large assembly. So if you look at this and you were thinking about this design and we were designing this fully with every part inside of it, this assembly would be huge. The amount of time it will take for this to regenerate will be more than we would really want to, but we understand it will be necessary. So of course we use things like simplified reps to go through and reduce what's being shown. But one of the things that we can do is create a shrink wrap of these parts. So instead of showing, every individual part, we can create a shrink wrap that just simply shows the external of that particular assembly or any of these pieces of assembly. So if you look in our model tree on the left side, we have this engine assembly, but if you look at those, these are all individual parts. These parts are representations of the assembly. So this is an assembly of the transmission, and you can see what this is saying is SW just simply refers to shrink wrap. So we've gone through and created these shrink wraps for each one of these, the generator, you can see all these different pieces that we've gone through and created all as shrink wrap. So when we look at this is literally a part instead of all individual items. So a shrink wrap allows us to go through, of course, speed up the regeneration, but not lose anything visually because we're still designing around this and we can see what it is we need to design to or design around without using the full assembly, which once again will take some time to go through and pull up into our Creo sessions. And then of course, we also have interchange assemblies. Interchange assemblies are great. It makes it easy to go through and replace components that may not be related to each other. So I can go through and have a part A and a part B, two completely different parts, but with an interchange assembly, I can go in and put in the part that is currently in my assembly and then reference it, or sorry, add the references to that second part so that now, however this first part was assembled into my assembly, I've now assigned those same references to part B and I can easily swap them out. So I can go through and simply swap out those parts within an assembly using an interchange assembly. We'll go through and talk about replacement functionality as well, because there are some enhancements to that. But an interchange assembly is one of those methods. And the benefit of an interchange assembly is you can have as many different parts in there as you want to. So we're just talking one-to-one, but I can have one part that I start off with and maybe have 4 iterations of that I want to be able to go through and swap it out for. So each one of those can be in that interchange assembly and I can seamlessly swap them out because I've assigned the appropriate references from the original part to all the subsequent parts in that interchange assembly. All right, so once again, some of the advanced functionality, as we talked about a moment ago, we will go through and talk about going in and using the replace functionality inside of our assemblies. So at this point, I will go ahead and start the demo. All right, so the first thing with the demo, I want to go through and open up. There is a large assembly I want to go through and open. And that assembly is going to be a train assembly. So we're going to start big. There it is. Now, just a few more seconds to finish processing. There it is. Now, if you look at that, you realize that came up pretty quick for this to be a train, right? So let's look at the individual pieces of it. So there's a top level, and then there's the passenger cars. So if we go in just real quick, I'll open up a passenger car assembly, and we can see what's in here. So here's that, and I'll come back to this as well because I want to show a little bit more. But if I come over and I look at this body, and I'm going to go ahead and hide that real quick, we can see what's in here. You can see there's chairs in here. Everything is represented, all lined up, all patterned. So this is the passenger car, and this is in here multiple times. I want to go ahead and look at the top level, and this is kind of what we had just looked at just a moment ago. And this is just representation. That's why I'm not as worried about some of those errors that we were looking at. I'm going to go ahead and hide that. Kind of similar to what we were looking at just a moment ago on that overhead. There's a lot of parts in here, a whole lot. So for that to regenerate as quickly as it did, either I have an awesome graphics card with a whole lot of RAM, or all the detail of these files are not here. So if I come over here and I open up this engine, if you look at this engine assembly, everything that we're looking at is a part. So we have created a shrink wrap of all of these files to make it easier to go in and pull up. As you can see, that alone is a single part, but you know from it being a motor, that's not one part. Same thing here. So we simplified this by going in and simply creating a shrink wrap of that assembly and now using that inside of my train assembly instead of the actual individual components. Now, we do have an assembly that has all this in here, but for what we're doing, we don't need to see that for what we're going in and presenting. So there's a time and a place to show all of that detail, but this just isn't it at the moment. So as you can see, there's quite a bit of information here. Now, as I mentioned before, we are looking at shrink wraps, but we also are looking at, there's a skeleton here. This skeleton is important because it also shows you the constraints of where everything needs to fit inside of. So when I go in and I open up this skeleton, we can see that information. So we can see what represents the ceiling. We can see where the doorways are. So we know that all of that engine and everything associated with it needs to fit inside of this area. So what did we do for that? Inside of this skeleton model, we've gone through and we've created multiple individual sketches. So a skeleton is simply built up of curves, curves, sketches, points, coordinate systems, datum planes, any datum features, and surfaces. A skeleton will not have any solid geometry inside of it. It will only be non-solid geometry. So when I turn on my datum features, I can see anything else that may be there, including additional datum planes that were created for sketching planes or reference planes or whatever was necessary. So when you look at my model tree, that's what you will see. So for that, when we go in and we start looking at some of these other items, no, this one isn't there. I'll show it in the other one. But what we will see is inside of these other components or assemblies, we've copied that skeleton or references from that skeleton. Because this was simplified, we did not go in and copy anything in there because we just simply used the shrink wrap components. We just wanted to make sure everything was fit properly. So if I close that and this one, and now come back and just open up one of the passenger cars again. So now we have the skeleton for the passenger car. When I open that up, once again, you can see the surfaces there. You can see the representation of where the windows are going to go, the doorways, once again, where they're going to be located, and then even the cutout for the trucks that are going to go in and be used in this assembly. So all of that is done inside of that skeleton model. So when we go back into here and we begin to look at these individual assemblies, one of the first things that it has is its skeleton model. And when you look in it, it actually has geometry copied from the original skeleton. And that's what we're looking at here. Now, I will show you this in a little bit more detail in just a little bit to show how we can go through and copy geometry, but I'm just kind of showing you the overview of this one right now. So, yeah. So we go through and use the skeleton model to go in and copy that geometry. And now when we go through and begin to manipulate our features or our parts, we're going to go through and use the geometry that we had from our skeleton model to go in and begin to develop properly our parts. So we'll just copy those inside of here. So what I'm going to do is I'm going to go through right now. We just talked a moment ago about simplifying things. So right now we have this assembly. We have this assembly of this truck. Now this has some detail in it, but for what we're doing, there's not a lot of necessity for its detail. We just need its representation. So there's multiple ways to do this. So I can come in here, I can create a new file and then copy everything using using shrink wrap, and now copy everything to that. Or I can simply take this, which is what was done in the front card, the engine card for the train. I can actually take this and do a file save as, and I can actually save this as a shrink wrap. So I'm going to save this entire assembly. Instead of it showing all these parts and assemblies, I'm going to save it to that shrink wrap. Now I can specify what to go through and save, fill in holes, all these different things. I can go through and specify that. Do I want to go in and use a real color? Do I make it grayscale? You know, are there some additional things I want to go through and use? Do I want to change the name of it? You know, or the level of detail. How much detail do you need to show? So with that, I can go in and preview it. It's just simply put it right on top of that so you can see it actually filled in the top here. So it doesn't show that. If that's what I want, great. If I don't want that, I can deselect fill in holes, do a preview again, and you can see that it opened up that area. So it still shows all the different holes in here versus going in and filling them in. So if that's something that we want to show, then we can go through and leave that there. So I'll go ahead and leave it where it does not fill in the holes, and I'll go ahead and say okay. All right, now that part has now been created. So now when I go in and I open, I can come over here and I'm just going to type in truck again. And here is that truck that was just created. And there it is. So this is a simplified version of it. As you can see, everything here is just external copies. It's just copying surfaces. There is no solid geometry here. How do I know? Because if you take this and you take it to wireframe, everything is purple or magenta. That represents it being a surface versus being an actual solid part. But once again, when it's shaded, it looks exactly the way I need it to look. Now, what can I do with this? Next. If I come back to the passenger car, I can take this truck and I can do a replace. Now at this point, I can go through and specify what I want to replace it with. So I can come over and find truck, this, open. Now, when I do that, it basically will tell me that I can't use that because I created basically as an external shrink wrap. But what I'm able to do is I can come over and I can do unrelated. I can back up. If I would have done it, actually, I guess I can do it real quick because it only takes a few seconds. My apologies. If I come back into here and I do create a new part, I'm going to call it truck -W solid. Yep, great. Put it into the default location. And now when I come over and do a shrink wrap, I want to come over here and instead of it just being internal, I want to be able to use it externally as well. Oh, sorry. I need to do something first. I need to make it active. Now I'll do my shrink wrap. And then once again, external, default location, great, great. And there it is. So now when I open up this one, it looks similar. Once again, It just has this external shrink wrap. So now when I go back to my passenger car and I go in and I say I want to replace, I can now once again type in truck session, say truck SW. Now that one it will use. The other one that I did, I created that basically as a separate part. I copied all the geometry and now it's a separate part from the original truck. This one, because I created within that truck assembly, still has a relationship to that truck assembly, so it allows me to go through and swap it out. So now when I go in and select apply, say okay, what it's doing, it's now going in and now asking me to reattach the references. So it's going in and now using the secondary one, and now how does it attach to the assembly? For what I'm going to do, I'm going to go ahead and cancel that, because instead of going in and doing it that way, this now brings up what we had talked about a moment ago, is I want to go in and create a new assembly. And it may be simple enough to go through and create, and reassign the references, especially if it's just a one-time thing. Then yeah, it may be simple enough to go through and say, okay, this is this, this is this, and reattach everything. Or we can come over here and create an interchange assembly. So with the interchange assembly, I'm going to go ahead and put the initial truck assembly in here. Great, there it is. And then I'm going to go through and add a second assembly. Now I have enough of them to choose from at this point. So I'll go ahead and use the one that I copied that did not sync properly, which is that shrink wrap 002, and say open on that. And I'll come over here and I'm just going to drag it back there, because I'm just using them as reference. I just need them close to each other, so I don't necessarily have to lock it down. There it is. Great. So now I'll go ahead and turn on my datum features. And now what I need to do is I need to specify the references that are used in this assembly to go in and assign them into this second assembly. Now to do that, up here is your reference parent. Select that. Now, which part do I want to use that is the original part? I'm going to pick the truck assembly. And it wants to know, because this truck assembly can be used in multiple assemblies, it wants to know which assembly am I assigning the references from. So what assembly is this in that I want to swap this with? So that's what it's looking for here. And I'm going to go ahead and pick the passenger car and the generic. And then I'm going to pair it with my shrink wrap. Create reference tags. Once again, I'm going to go in and use the original passenger car, and there's the ones. So I can have evaluate. Now, I'll show you another one where this comes in really handy, because it can reassign it if I just create a copy of it. But for this one, I need to go through and now assign appropriate references. So here's my first reference. That datum plane, I want it to now be this datum plane. For this reference, it's currently using this datum plane. I'm going to assign it to that datum plane. And then for this one, I'm going to assign it there. So now everything that is used. Now for this one, because it is only being assembled into the passenger car, it only gives me the references that are assembling it into the passenger car. If there were things that were assembled to it, I would also have those listed as well. So any child references that it may be using from another part or for another part will also be listed here, so everything swaps appropriately. But once again, the only thing I'm assigning on this is assembling it into the truck, into the passenger car, sorry. All right, so now that that is done, When I go back into the passenger car, turn on my datum features, and I come back to this truck, right click and say I want to replace, it already recognizes that that truck is a part of an interchange group. Excellent. So I'm going to go ahead and say open. Now, if it was a member of multiple interchange groups, they would all be listed here. When I come over and expand this interchange group, it just simply shows that one additional one additional component that I'm using. But if I had multiple parts inside of that interchange assembly, they would all be listed here. So I'm going to go ahead and just pick the shrink wrap part, say OK, and I'll just say apply. And then I can do the same thing again with this one. Now over here, you can see that it is replacing this assembly with that assembly. I'm doing the same thing for the second truck assembly, same scenario, replacing it with that. Now when I say OK, they both get replaced in the assembly. So now once again, for regeneration purposes, this will regenerate faster because it does not have to regenerate all the features of the parts that were inside of that truck. So we can do that for multiple parts. That's once again, when we look at that, where all the engine components are, remember, they have that entire engine listed as a single part because it's simply a shrink wrap. And that's what we have here. So this entire assembly is actual single part file of surfaces. So that makes it a lot quicker and a lot easier to go through and regenerate your assemblies. All right, so that's this one in a nutshell. Now, I will tell you that if you are using an interchange assembly, it is a required item. So anyone that has used Windchill and has had parts that they brought into Windchill that were associated with a interchange assembly, a lot of times you may see, I would say, if the interchange assembly does not exist and is not active, you will see that listed as an item that will show up as a ghost object. Because it is something, because the reason this part is in here is because of the references that were created in the interchange group with the other part. So that is something that needs to tag along. So I say that to say, if this just a one-time swap, so maybe it's not a shrink wrap, it is an actual second assembly that we wanted to go through and swap out with permanently, then I would go through and do the replacement of this and just go in and say unrelated object, pick the object, and then at that point create the references between the two. So you would do it that way for this one. That way there is no interchange assembly and you swap it out. It may take a little bit of time, once again, depending upon how it's assembled and what may be assembled to it, because it's replacing all of those references at one time. So, but once again, it's just a one-time deal. So if it's just something that you need to replace once and not something you're going to go through and try multiple iterations of or multiple versions of, that an interchange is not useful for, then yeah, I would not use an interchange assembly. So just a word when going in and thinking about using interchange assemblies. All right, so I'll go ahead and close these out, including that, erase everything. And now I'm going to go in and open up one other part, a little bit smaller than the train, but just as functional. So same thing here. We have this simple assembly, but this assembly has a skeleton. When we look at the skeleton, we can see that they've gone through and laid out the key areas, the top profile, the bottom profile, and even the end of it. It's not, and you can see curves are overlapping each other. That's fine. It does not have to be a clean skeleton. You're going in and using references where necessary. We'll use the geometry to go through and lock in based on the appropriate geometry or appropriate references. So you can see inside of here, we also have what are called published geometry. When we're going in and using or creating copy geometry, excuse me, from one part into another part, you have the ability to go through and copy anything or be very specific as to what is being copied. So when I go back to this top level knife assembly, I'm going to go in and I want to create another handle, but I'm going to create another handle and I'm going to use the curve geometry. So in here, I'm going to go ahead and just create a brand new part. Same thing, I'm going to call this handle dash improve, because we don't do things, we improve everything. There we go. Once again, default, and I'm just going to go ahead and, of course, put it in a default location so it's there. All right, so there is that part now. So now if I come over here and I say make it active, and then I come over here to copy geometry. Copy geometry. So up here in content, there is this option for publish geometry. Publish geometry will only allow me to select geometry that has been designated to be copied. If I don't select that or have that deselected, I can copy anything. So if I go to this skeleton and expand it, up here are all the original curves. But if you notice, as I'm selecting them, they're not going in and being selected. If I come down here to the bottom and pick on publish geometry, it now goes through and selects that published geometry, because I've designated that you can only use published geometry. If I deselect this, then I'm able to pick any surfaces, any bodies, any chains, any additional references that I want. So at this point, I can pick any geometry that I want to go through and use for my assembly. So, but for what I want to use, when I look at the skeleton model and I look at the published geometry, it's kind of just little pieces of it. What I want is I want to create a piece of published geometry that has this top curve, this back curve, and the bottom profile in there. So to do that, I can do it multiple ways. Underneath tools, there's this option for published geometry, or if you're on the front page, there's model intent published geometry. It does the exact same thing. At this point, I'm now gathering the information that I want to go in and use as my published geometry. I'm going to go ahead and pick chain. I'm going to pick this top, the back, and the bottom. Select OK. And now it creates that published geometry. Now, right now, it is labeled as published geometry, which is the same as all the rest of them, except for that one that I changed. But what I can do is, as I'm going in and creating this, I can go into the properties and I can call this handle profile. And now it's labeled as handle profile. So now when I go back into this assembly again, and I make my handle improved active, and I say copy geometry, I'm going to leave it at published geometry. But now I'm going to come over here into my skeleton model. Under the footer, there is my handle profile. Select OK. Great. Now I'll come over here and open up my handle. And there you can see the curves. So what do I do now? I go in and select on my front datum plane. I say I want to extrude. I'll go ahead to my sketch view, just so you guys can see the profile. And I'm going to go ahead and copy these. So select project, and I'm just going to copy each, control key, each one of these into my sketch. Now, as I mentioned before, it doesn't matter that they overlap in my skeleton model, because I have other tools to help me clean up that geometry. Oh, sorry. I do need to close it. So I'm going to create curve here to here, and right about there. Great. So I select OK, go ahead and give it a width. I'll give it a width of 1, and I will also go ahead and make it symmetric. Awesome. So there's the beginning of my handle. So when I come back into the razor knife assembly, there's that geometry. But if you notice, my geometry actually is a little bit too big. There is an additional profile in here that I actually need to copy. So what I'm going to do is in my skeleton model, I'm going to come into this handle profile, edit definition on it. What I need to do is I need to go in and add this additional curve to basically give an end to the profile. I'm sorry, the curve up here. So I'll come in here, hold down the control key, and I will select that curve there. Great. So now that has been updated. So if I come over and I look at or expand my footer, you can see it has that additional curve in there. So when I come back to my handle, initially it doesn't show it, only because inside of here I haven't regenerated it yet. So I'll do a Control G to regenerate. So now when I select it, you can see it shows the updated geometry that I need. Go into the extrude, edit definition, edit my geometry, take this, delete it, come back over, add this, and then of course, trim it to here. And then I'll also bring it down a little bit, 0.5, so it's not as big. And now when I go back, there it is. You can see it fits that same general profile. Now what I do on the sides could be different, or whatever, but right now I have my handle that has the appropriate profile for it. Now, what is the other benefit of having the geometry? So if I come over here, or sorry, having the copy geometry, if I come over and I decide that this bottom profile in my skeleton or my knife needs to change a little bit, I can come over here, select the bottom profile, and once again, edit definition. Now, because of the way it's created, this is basically a curve. So I can come over here and begin to manipulate its shape a little bit. Say, okay, there it is. Now, how does that affect all the other parts that reference that? So it's here, it is a copy geometry here, and then that copy geometry, I'm sorry, the published geometry, the published geometry is now copied into other parts. So when I Control G and everything regenerates, there it is. So because the profile or my main objects are controlled by the skeleton, when I decide to update that skeleton geometry, everything that uses it also updates immediately. So that's where we talk about that top-down design, where the skeleton is your top. And then you go in and manipulate things going downward. So that is the benefit of using top-down design inside of here. There is one other thing. This one is fine, but just for fun, this is a knife that usually collapses. We don't have that functionality in here just yet. So if I come over here and I select on, I think it's the holder, yep, the holder, and I do an edit definition on it, the way it's assembled, you can see it's planar there, you can see it's coincident here, and then there's an angle here. Well, I want to be able to go in and convert this to being a mechanism so that we can actually rotate this. So what I'm going to do is remove this angle, because right now I can use this angle to go through and manipulate it, but I want to be able to drag it. So I'm going to select on this angle offset and say delete. Right now, I still can't do it because that's what this icon is here, is converting it to a mechanism. So although it only has these two constraints, it still has the checkbox for allow assumptions, which allow assumptions basically removes a degree of freedom that may be left. So if I uncheck this, you will see that my 3D dragger comes back up, and now it allows for its rotation along that axis. Excellent. At this point, I can just select OK. And now when I say drag, I can pick on this, and then I can freely rotate this. Now, no, I have not gone in and constrained it to go in and lock it down so it only moves within certain angles, but that is possible for you to go through and do, to go in and lock it out so it only goes up so far and rotates so far around. We have another webinar that we've dealt with mechanism and how to go through and create those constraints, so you can always look that up as well. There's also a class on mechanism that gets more into mechanism functionality. So all that's in there. So we can also go in and create different snapshots that we want to go through and create. So I can go through and say, okay, I want to maintain that position. I'm gonna move it. I want to see it in that position. And I want to go ahead and move it again. And I want to see it in that position. And do it again. Now, this is also something that is useful for drawings. So I can actually use these snapshots and be able to use those in drawings for this. So when I go back to each of the snapshots, it shows them in those different locations. And once again, these snapshots can be available inside of a drawing so that we can show them in those positions as well. There. Now, this functionality that I'm showing you here is basic functionality. So this is available in just your regular Creo license. You don't need Advanced Assembly extension. All right. And one last thing, I'm going to pull up the truck assembly just one more time for you. Let's erase everything else, and then we'll be done. Because I want to look at the replace functionality. So we have, let's just say I want to go to the very top. I know that this part here has children because it's the first part. Everything is tied to it, but I want to replace it. There's multiple ways of going in and doing that. One way is if I come over here and I open, and once again, it depends on how we want to go through and drive it. But if I come over here and I open this up, I can come over and just simply do a file, save as, save a copy, and I'm going to call this truck chassis model dash improve, because once again, everything is better. And just so we can see it, that one, I'm going to go ahead and just change the color so we can actually see the differences in that one and another one. Great. So what I can do is now go back into here. I can select this, same thing, right click, replace. And I can replace this with a reference model that we don't have. We can do a new copy or an existing copy. I just created a copy of this part. Select it, open, select on improved. Okay, that's fine because it's just a color. Say okay, there it is. So now in my assembly is that new part. Because I copied it from the original part, it allows me to easily swap them out because all the references are the same. Now I can begin working on this one without affecting the original. Or I can take this, once again, right click. I created it outside of the assembly, but I can also come over here and say, create a new copy directly in this assembly. Give it a name. super improved. Say okay. And guess what? Wait a minute. Oh, sorry. Too many letters. New copy. Let's just call this one better. The best. There we go. And there it is. So now that one is in there. Now, if I go in and do another replace on this, I don't have existing copy. Remember the original one, I want the original back. But because of the way things were done, they're not related. But what I'm able to do is come over here and say, okay, I want to go through and do an unrelated file. What is the unrelated file? I'm going to go back to the original truck. That one. Now, at this point, I can come over here to the reference table. So remember what we did when we did the interchange assembly? That's equivalent to what we're doing here. So now this is where I said we can easily swap things out. I can go in and say edit reference table. There it is. So it shows the current part and the part that I'm replacing it with. Right now, because they are the same file, if I come up here and I tell it to evaluate, what it's going to do is see if the references in this part, if there are equivalent references in this part. And when I do that, it sees that they're basically the same file because it shows that it's the same history. I can now come over and say, okay. And then say, okay. And now we're back to the original model in the assembly. I am using Creo 9. There was a question on what version of Creo I was using. I'm currently using Creo 9. So there may be a few dialog boxes that may be different than what you're seeing, depending on, even from 7 to 9, there's a few little tweaks that they've done. So, and I know some of the interchange stuff or the replace that I'm using, I know that stuff is new. So those are in newer version, the newer version of Creo. So that's where you'll see some of that. So this is also kind of a Creo update too. So that is everything with this presentation. So if there are any additional questions, if there aren't any questions, then once again, I thank you for your time. I just remembered. Yep. We are available for any training. We have advanced assembly training, which covers some of the topics that we have here. We can do that virtually in center at one of our training centers, or of course we can come on site if it's more economical to bring us on site because you have more people that you want trained. But you can always visit our website for our training schedule. We do have our training schedule out, I think, at the moment through the first quarter of next year. But if you do want a custom class, please feel free to reach out to us. Or if there's something on our calendar that or not on our calendar that you're looking for, once again, in Wimberley at PDSVISION.us. You can also reach us for any questions on sales. If you don't have advanced assembly and you want to know how much it costs, reach out to us. We can let you know. Of course, visit our website, PDSVISION.us. Of course, look for us on YouTube. This video will be on there and any other videos. Remember, I mentioned mechanism design extension. That's on there, so you can see additional things that you can do with mechanism if you want to move things around. Or just some of our other videos, whether we're dealing with CAD, Creo, or Windchill, or any of the other products that we have as well. So we've just recently done one on KeyShot as far as the visualization piece of it. Very, very powerful piece of software. But once again, if you want to reach out to us, please feel free to. And thank you for your time and enjoy the rest of your day.